I've got a lot to do this year, so that's why I built this. I'm a software engineer, so I have code to write. I'm creating 3D printed projects in Blender. I need to edit videos for this channel, along with creating all of the art that goes with them. And so I want to build a PC that'll be able to handle all of these tasks. I also want my PC to handle any current or upcoming games, fit on my desk without taking up the entire thing, and to be visually appealing. So that's why today I'm creating my ultimate ITX PC for productivity and gaming. So while each of the components or parts that I chose here are tailored around my personal needs, my hope is that as I explain my reasoning for each of them, it can help you decide what is most important for your build so that you can also build your best productivity machine. A lot of times, at least for me when it comes to building small form factor, I start with a particular case in mind, as that's what can drive a lot of the component choices based on what's compatible. For this build though, because I have workload considerations, I'm going to be going the traditional route when it comes to planning by picking out a few of my key components and seeing what kind of case I can fit it all in. And let's start with the CPU. So for me, it came down to a few different options. I could go with the Intel i9-14900K, which is one of the best that Intel has to offer right now, but considering how minor of an improvement this generation of chips are from the 13th gen, and the likelihood of this being one of the last releases of the LGA 1700 socket, I decided to go instead with AMD. Now, the 7000 series from AMD is on the new AM5 platform, which they claim to support until 2025. And so any motherboard that I choose from here could theoretically last me a good long time. For productivity only, there are some good options out there, like the 7950X and the 7900X. But if I'm being honest with myself, I know that I'm gonna be wanting to game on this as well. And so that 3D V-cache that's offered in the 7950X 3D is gonna have a massive impact on gaming performance. Now, looking at some stats from Tom's Hardware, it looks like we can expect only a minor hit in productivity performance by going with the X3D version. However, if you look at the gaming benchmarks, there is a huge difference in favor of it. All of this to say that if you don't game, I wouldn't spend the extra money on the X3D variant. But if you do, it could be worth it. Now, the Intel i9-14900K does have a slight edge when it comes to productivity tasks and is a well-rounded CPU. But I also like the lower power consumption of the AMD chip, making it easier to cool, which is definitely going to be a major benefit when building small form factor. And so with the CPU picked out, we need to figure out what motherboard to plug this into. And the options for ITX AM5 motherboards are still, fairly limited, so I've narrowed it down to a few different options. The first is the Asus X670EI. This is an expensive and pretty overbuilt board, but it does have some pretty compelling features that I think could be useful. Two M.2 drives under this massive heatsink that's actively cooled, but the main draw for me is the two USB 4 ports on the back so that I can get the fastest data transfer speeds between external drives. The downside being, of course, that the price is over $400, and I wish at that price they would have given a third M.2 slot on the back. Now, another good option could be the Gigabyte B650i AOS Ultra. It does have three M.2 slots, so there's a ton of room for fast storage, and it's a lot less expensive at $240. The downside here is that you have to use a daughter board for some of those front panel connections and other features. Now, while I totally understand the reasoning and the limited space of an ITX board, it can still be annoying to work with. Ultimately, I decided on the MSI B650i Edge for a few reasons. First is that it matched the all-white aesthetic, which, while not the most important thing for me in this build, was still a big bonus. It also supports up to 7200 MHz memory overclocking, which I do plan to take advantage of, and it has all the I/O that I would personally need, including USB-C 3.2 port for that fast data transfer. On top of that, you still get built-in Wi-Fi 6E, and while it doesn't have three M.2 slots like the Gigabyte board, it does at least support two. One under this actively cooled heatsink on the front, where I'll be putting a 2TB 980 Pro, and then the other on the back that I can utilize later on. Now, if you're working with those large files like I am and need quick access to them, having those extra M.2 slots is going to be really valuable, as that's going to give you the fastest storage. Now, while I still definitely need fast storage for my files, and I'll likely be populating that back spot with another 2TB stick soon, for me, I also plan to move all my large files onto a NAS system, like the one from this video's sponsor, Ugreen. Now, they sent this over to me ahead of its release because they have a Kickstarter thing going on for this new line of systems that they're launching in the coming weeks. This is the NASync DXP 4800 Plus, and these are made for mass storage that's accessible to any device connected to your network. Now this is going to be really useful so that I can access any of my files from any of my computers at home instead of being tied up to one PC or a single location. Now the one I have here has 4 bays for SATA drives, plus an additional 2 M.2 drives with a total storage support of up to 96 terabytes, which should be more than enough for all of those large video files and anything else for the foreseeable future. What's interesting about it though is that it's basically a small PC specifically designed around mass storage. It's got a 12th gen 5-core Intel processor, expandable memory. This one comes with 8 gigs of DDR5 4800 installed, but it does support up to 64 gigs and a lot of the I/O that you would see in a typical PC. It's got 10 gigabit Ethernet along with HDMI out, so that you can directly connect this to your monitor with a mouse and keyboard if that's easier for your setup. Now, of course, like other NAS systems, you also have remote access to your storage through a desktop app or even from your phone so that you can search, upload, or download any of your files from anywhere. Once we get this all unboxed here, we just need to install the 4 drives. The faceplate for each of the bays pop open so that you can pull out the hard drive tray. These trays are also toolless, making for a very easy setup. They slide open on one side, giving you enough room to insert and secure the drive. Then you just push each of the drives back into the system. I'm starting off with 16 terabytes, so that's 4 4-terabyte drives. And after a brief setup process, we are ready to start transferring files. If you want to check these out yourself, I'll leave a link in the description below. They have a few different models coming out for a range of different needs. Now, RAM is actually pretty important for a productivity PC. If you're working with really large image files or anything that needs to hold a lot of system memory, having enough to go around is going to make a big difference to the overall speed of your machine. So having a bunch of large files open, a bunch of tabs in your browser, this is all going to use more memory. And so if it's in your budget, I would go with as much capacity as you can. Now for me, in my workload, I've found that 32 gigs of RAM to be enough, but of course, everyone's projects and needs are gonna be different, so you might feel more comfortable with 64 gigs. Now, if you're a heavy Blender user, then 64 gigs would probably be better. For me, in the projects that I'm working on, 32 is enough. This being an ITX board, we're only gonna have access to 2 DIMM slots, so you'll wanna keep that in mind that unlike micro ATX or ATX boards, if you go with 32 gigs now, you'll have to outright replace those 2 16 gig sticks with 2 32 gig sticks if you wanna make that upgrade. Now, Photoshop requires a minimum of 8 gigs of RAM, but recommends 32. Same for Lightroom. 32 is also the recommendation to edit 4K video in Premiere Pro, as well as the recommendation for Blender, which covers all of my heavier RAM uses. I'm gonna be using this DDR5 7200 CL34 kit from Team Group. Aesthetically, this is probably the cleanest looking set I've seen yet. They are capable of up to 7200 megahertz, which is the max that my motherboard will be able to support. And to utilize that, we'll also need to make sure we select the overclocking profile in the BIOS. Now, those faster speeds will allow for faster data transfer from the CPU to the RAM, resulting in faster overall performance. Now, 7200 though is gonna be overkill for most people. I would actually recommend DDR5 6000 as that's gonna get you the best balance between cost, stability, and performance. Anything over that would probably be a waste if you're just gaming, but it can make a performance improvement in productivity tasks. But again, capacity is going to be more important than these overclocking speeds for most creators. So I would still make sure to get as much capacity as you can. Now, when it comes to the GPU, for an ultimate productivity and gaming machine, there's really only one choice in my mind, and that's the RTX 4090. Now, the one I have here is the Aero 4090 OC from Gigabyte. This card is absolutely massive, so it's definitely gonna be a challenge to fit into a small form factor case, but you really can't argue the aesthetics. This thing looks super clean in my opinion. The all white and silver shroud surrounding the triple fan setup looks super nice. The aluminum backplate is a clean all silver design as well, which is also where you can find the dual mode switch so that you can choose between the default overclocked BIOS or the silent mode. From the side though, you can really see how thick this cooling system is. It's got an insanely large heatsink, making the card 75 millimeters thick, which will take up almost 4 slots. So that's definitely gonna limit our case options, but it will hopefully result in cooler temps and lower noise levels. I've got to admit though that the Aero line of cards from Gigabyte is probably my favorite from any of the other partner cards, especially if you're going for an all white build like I've got here. The reason I'm going with a 4090 specifically though is for a few reasons. The first is that NVIDIA cards are generally better for creative and productivity tasks due to the NVIDIA CUDA cores. Adobe programs like Premiere are better optimized to work with NVIDIA, and 3D modeling performance is typically much better with NVIDIA than AMD. The second reason is that it comes with 24 gigs of VRAM, which will be really useful when using Blender and also when working with higher resolution video editing. And lastly, of course, because this build is centered around productivity and gaming, it's also the best gaming GPU available today, no question. Now, if you're a photographer or video editor that's working with 4K or lower resolution video, then you really don't need more than 8 gigs of VRAM. But if you're editing 6K or 8K video, you'll want more than 10 gigs of VRAM. And for 3D modeling, the more the better in my opinion, for those bigger renders. Okay, for the case, I decided on the Meshroom S. First, because it can fit this massive GPU. It has enough room for a 240mm AIO so that we can properly cool the 7950X3D. I like the look, and I find it really easy to work in. I built in it for my downsizing video, where I was really impressed how I could fit nearly everything from my 50-liter pre-built into this 14.7-liter case. My biggest piece of criticism about this case is while I find the build quality of the frame to be excellent with a very smart design, the mesh panels are not as rigid and they can bend very easily. Combine that with the stiff push pins and you're at high risk of bending a panel. And while you can attempt to bend it back, it's gonna be pretty difficult to get it perfect. In fact, you might even make it worse. So if you do get this case, just be really careful the first time and try to pull as close to the actual pin as possible to avoid bending one. Otherwise, the all mesh panels do look really good in my opinion, especially in all white. Now, before we can start putting the components in, we need to get this case properly prepped for a 4-slot GPU. So that means we need to shift that center motherboard tray closer to the motherboard side by replacing the spacer with a shorter one that's in the accessories box. Then remove the remaining 4 screws on the side and bottom, shifting it, and then resecuring it. We also need to move the GPU mounting struts to the second to lowest position so that we can allow for a 342mm length GPU. Now, because this GPU is so long, I'm also going to need to add the case feet, which you would have to pick up separately. This will give us enough room under the case so that we can plug in our DisplayPort or HDMI. All right, now with the case prepped, we can start by dropping in and securing the motherboard. And now, because we shifted that center, that does leave us with a lot less clearance for the pump block on our AIO. So that's gonna reduce our options here. In 3-slot mode, we had 74mm of clearance, but now we only have 54. So I'm going with the Corsair H100i RGB Elite. Now I've used this one in the past and I was really happy with the cooling performance. I believe that the pump block is 55mm in height, so it will be pretty close, but I think it should fit. It's also got that all white aesthetic and minimal RGB. We only have a ring around the block, which I think looks pretty tasteful, and no RGB fans. So we don't have to worry about all those extra wires. Now, originally I was gonna have the fans as intake on the front, but I'll later figure out that the tubes from the radiator are going to get in the way of the GPU. So I ended up having to put the fans on the inside with a grill so that I can protect them from the cables. Something to keep in mind if you're running a larger card like I am. Now, once the fans are installed with the mounting bracket, we can lower the radiator into the case and then secure it. And then attach the water block to the CPU. Now, another reason I do like this AIO though, is that it has a single breakout cable that connects from the water block to the fans, the fan header, USB, and the power. And while we're plugging stuff in, we might as well get our case cables in as well. So that's the USB 3, USB Type-C, and the power button. Then we have the pre-installed riser cable just conveniently hanging out right where we need it, so we can plug that in as well. Now for the power, I'm going with the Asus ROG Loki SFX power supply. It's 850 watts, which is the recommended spec for a 4090. Well, at least for a Founders card. The Aero card recommends 1000 watts, but I think we'll be okay here. It's 80 plus platinum rated, so that's the second highest for efficiency, and it has these really flexible, almost white cables that make it easy to manage in the smaller cases, including a dedicated 12-volt high power connection. It's a really good but admittedly overpriced power supply, but come on, it's a pretty damn good looking one. With the motherboard, CPU, and SATA power for the AIO plugged in, there's only one piece left, and that's the graphics card. So this is a little bit of a pain in the ass to install, but it's not too bad. So first we just need to take off the top bar. Simple enough, 4 screws on each side, and then we can put that aside. Then after a few minutes of trying to figure this out, it didn't look like any of the holes to mount the riser cable aligned where I needed them to be. So I just took the standoffs off, and with the card out of the case, I plugged it in along with the power cable and then lowered it into the case. Then just kind of slowly maneuvered it down into the position so that I can finally secure it to the case. Then the last thing to do there was to resecure that top bar, and it was a perfect fit. It's a little hard to show on camera, but the bar actually isn't even touching the top of the GPU. It just has a few millimeters of clearance. And with that, all we have to do is resecure the mesh panels, and that's the build complete. Now, I was a little worried about the CPU thermals with the fans being on the inside, but as it turns out, the temps are looking great, even better than I was expecting. Testing Horizon Forbidden West at high settings in 4K, and I'm seeing mid to high 50s for both the CPU and the GPU. And this is with the mesh panels on. Noise levels are very reasonable as well without any whining or turbulence. So let me know if you like these more productivity focused builds. Maybe I'll do more in the future and come up with a testing suite to compare them if this all goes well. So thank you so much for watching, and I will see you in the next one.